Okay, again, here are the rest of what we talked about in class in regards to the nutritional labels. So again, if you haven't tried 4 through 7 on your own, after doing 1 through 3, go ahead, watch the videos, but now try 4 and 7 on your own. Just good problem solving, see if you can figure them out. And again, after you give it a good 10 minutes, 15 minutes, if you're stuck, then watch the video. But at least give every problem a try. Do something. Even if it's wrong, it's better to do something than nothing at all. All right. That said, if you need to do that, pause and then watch. If you've already done that, then I'm assuming you should be watching. So let's look at number 4. This one says find the number of calories per piece. Now, rates are awesome in math because the units don't match and it actually tells you what to do. So find the number of calories. So it's telling you what to do. Calories per piece, right? And again, the word per is division. So kind of like miles per gallon. You take your miles divided by your gallons to get your miles per gallon. Or dollars per hour. You take how much money you made, how many hours you worked, divide to get your dollars per hour. So rates have 2 different units. Ratios have the same unit. All right, so let's look at calories per piece. So if you look, there are how many calories in the bag? So 170 calories. And I know that goes first because it told me. Per, and then how many pieces does it say? It says there are 16 pieces. Now notice when you divide, your units don't cancel, so you need a unit of calories per piece for a label. So you're definitely going to have a label here, and then when you divide, you get exactly, what is it? 10.625. Right, so about 11 calories per piece if you divide. So again, not a bad snack if you can eat just 3 or so of them. You know, you're looking at 33 calories, not too bad. All right, let's look at number 5. Assume you have a 2,500 calorie diet. So not everyone has a 2,000 calorie diet. It kind of depends on height, activity, things like that. I think I read somewhere Michael Phelps eats 10,000 calories a day when he's training because he just burns so much up in the pool. So again, you and I probably don't need 10,000 calories a day, but again, depends on what you're doing. So if you look at a 2,500 calorie diet, what percent of the daily allowance of carbs does he consume if he eats the whole package? So again, remember earlier on that label, we had carbs, right? And it said 35 grams. Right, and then it had that 12% over here. But that 12% is based on a 2,000 calorie diet. So it's not going to be accurate for someone who eats more calories than that. So if we focus on that 35 grams, right, and then what do they want here? 35 grams, and they want to know a percent. So again, a percent, the unit has to match. So this is grams of carbs. So we need to look at the total grams of carbs for someone on a 2,500 calorie diet. So if you look at that second column, 2,500 calorie diet, they need 375 grams of carbs in a day. So again, the units cancel, and you're going to divide, and you're going to turn that into a percent, which is about 9.3% or about 9%. And again, that's different than this number because this person is on a 2,000 calorie diet. This person is on a 2,500 calorie diet. So it's going to change the percentages. And notice a percent is what we would call a ratio because your units cancel and it's unitless, where a rate would be like up here where it's calories per piece or something like that. All right, let's look at number 6. How many calories are there per gram? Okay, so if I look at that, it tells me calories per gram. So they're looking for a rate, which I love because it tells me what to divide, which is awesome. So there are how many calories in a package? So you look at the label, there are 170 calories per, and then how many grams? So if you look at the top, all 40 grams, so it looks like the entire package is a serving size. And again, notice your units don't cancel, they're different. So if you divide here, you get 4.25 calories per gram. All right, in your junior mints. All right, so now let's go down to number 7. All right, so number 7, the label says there are 30 calories from fat. How did they get that? How accurate is it? All right, so again, if you focus on fat, what we know about fat is if you look at the label and you focus on fat, there are 3 grams of fat. So somehow we're going to have to do something with 3 grams to figure that out. So we have 3 grams of fat. And this semester we'll do dimensional analysis. So right now this might look kind of foreign to you, but eventually as the semester goes on, it'll get better and better. If you look at the very bottom of the label, it says that there are 9 calories per gram. So if you look at that, there are 9 calories per 1 gram of fat. Okay, notice carbs have 4 calories per gram and protein 4 calories per gram, but fat's high caloric. All right, so notice the units of grams of fat cancel, and so this math tells us that we're going to multiply. So we get 27 calories. All right, now if you look at the label, they say 30, but again, a lot of times when they make the labels, they round and things like that. All right, and again, dimensional analysis, if you're like, well, can I just multiply? The answer is yes. But as we do harder problems, dimensional analysis will be a nice thing. All right, and then if you look at the top of the next page, page 26, I kind of talked about this earlier, but we will restate it here. So a ratio doesn't have a unit on it. And when I say that, I mean it kind of loosely. For example, I might say the ratio is 3 to 4, and it might be 3 girls to 4 boys. But again, it's kind of like students to students. So in a sense, there's no unit there. So it's 3 to 4. Okay, so there's 3 girls for every 4 boys. Or you might think of it as 1 to 2. And so this might be like with a punch. So maybe you have red, pop, and then maybe 7-Up over here. So notice we don't really have any units. So it could be 2 gallons of 7-Up to 1 gallon of red pop, or 2 liters of 7-Up to 1 2-liter of red pop. Or it could even be 2 cups of 7-Up and 1 cup of red pop. And that ratio is consistent, so they're all going to taste the same. So again, ratios tend to be unitless. All right, and rates have 2 different units floating around. So again, like I talked about, like maybe you drive 60 miles per hour. So that means you're going 60 miles for every 1 hour. So again, you have 2 units floating around when you're dealing with rates. All right, the last thing I want you to do is make sure you read problem number 8 and think about it, and we will go from there.